When you type a prompt into a large language model, the response feels instantaneous. It almost feels invisible, like the answer is simply being plucked out of a weightless digital ether. But the reality of generating that single answer relies on a grinding, massive expenditure of physical energy. Every time a server computes a new token, it demands actual physical watts of electricity. You might assume the global AI race is fought entirely in quiet software labs by programmers optimizing code. The actual front lines look very different. Companies are currently scrambling to secure hundreds of acres of raw land, pour millions of tons of concrete, and burn vast quantities of natural gas. The tech industry has reached a physical limit. The constraints of the material world, specifically the availability of land and power, now dictate the pace of digital expansion. Last summer, top technology executives, institutional investors, and political leaders gathered for an energy summit in Pittsburgh with a single objective: figuring out exactly how to keep the servers running. This chart contrasts historical tech investments with the new regional commitments. We see a massive spike of over $90 billion. Split into segments, this capital overwhelmingly favors physical power generation, like fossil fuels and nuclear, over wind and solar. AI computation requires massive, uninterrupted baseload power. Data centers cannot pause their operations when the wind stops blowing or the sun goes down, making intermittent renewables a difficult fit for round-the-clock computing demands. To bypass the limits of an already strained national transmission grid, the industry is turning to a strategy called co-location. They are securing land right next to natural gas and nuclear plants to build their server farms, feeding the generated power directly into the hardware. The limiting factor for the most advanced neural networks is no longer algorithmic efficiency. It is the sheer number of gigawatts a company can generate and route through its cables. Meta's president, Dina Powell McCormick, recently described the deployment of artificial intelligence as a mandatory group sport. Traditional energy executives now wield direct leverage over the pace of digital innovation because they control the physical fuel required to sustain it. Before a single turbine can spin, these joint ventures face years of bureaucratic delays. Government permitting for new power plants is now a far more severe threat to AI development timelines than any software bug. This graph tracks the projected labor requirements for the physical build-out. To wire this new power infrastructure, the United States is facing an immediate deficit of 500,000 blue-collar electricians. The most sophisticated digital technology ever created is entirely dependent on hard labor, creating a surge of high-paying trade jobs in cities that spent decades losing their industrial base. The next major leap in artificial intelligence rests directly in the hands of the people operating heavy machinery and wearing hard hats. The shift into the AI era has triggered a heavy construction boom on a scale rarely seen in modern history. Initiatives like Meta's compute strategy make it clear that tech corporations are pivoting. Securing vast tracts of land, industrial water rights for cooling systems, and thousands of tons of raw materials is now a primary corporate objective. Because this physical footprint spans entire states, political leaders from opposing parties are finding themselves forced to collaborate. Decisions made in local zoning meetings and state capitals dictate the timeline for global technological supremacy. We spent decades imagining the internet as a pristine, weightless cloud floating above the real world. That illusion is breaking down under the sheer tonnage of the required hardware. Institutional capital is following the concrete. Major Wall Street asset managers are redirecting their focus away from pure software startups and pouring billions into heavy infrastructure joint ventures. The period where Silicon Valley could scale infinitely while ignoring the physical constraints of the planet has ended. Moving forward, algorithms alone will not determine who leads the tech industry. Whoever holds the heavy physical infrastructure and the raw materials will ultimately control the future of artificial intelligence.